Hello everyone. This is Sagar from Sagar Institute of Research and Technology. Welcome you all. In today's session, we are going to discuss about the annealing process. Also, it is known as full annealing process or conventional annealing process. In the earlier session, we have discussed about the types of bulk heat treatment process in brief, in which we have discussed briefly annealing, normalizing, mass tempering, tempering, and mass tempering. Now, from today's session, we will discuss about the bulk heat treatment processes one by one in detail. So, let us start this session with the topic annealing heat treatment process. Yes, so this is annealing or full annealing or conventional annealing process. So, dear students, if you are studying in the third semester under the University RSB Bhopal, so this is important for you because one question or two questions are framed are asked from this topic in the university examinations. So, what is annealing or full annealing or conventional annealing process? So, this process is carried out by the following three stages: heating, soaking or holding, and cooling. Under heating, the metal or alloy is heated up to about 50 degrees Celsius above the A3 curve or hypoeutectoid steel. So this is very important. In earlier session, many times I discussed under the first stage, that is heating, the metal or alloy or component is heated up to a certain temperature, and that time I told that this certain temperature, this different temperature we will discuss when we will start the particular heat treatment process in detail. So this is the certain or definite temperature up to which temperature the alloy or metal will be heated. Okay. In annealing process, this is the certain temperature about 50 degrees Celsius above the A3 curve, but for hypoeutectoid steel. Hypoeutectoid steel means in which the carbon content varies from 0 to 0.8%. And if the metal or alloy is hypereutectoid steel, so what will be the certain temperature, definite temperature? So it will be 15 degrees Celsius above the A1 curve. So if the component or alloy is hypoeutectoid steel, the certain temperature up to which we have to heat the component, that is 15 degrees Celsius above the A3 curve, and about 50 degrees Celsius above the A1 curve for hypereutectoid steel. So this temperature range is very important for the annealing process. Then second stage, sorting or holding. After over stage one, the metal or alloy is maintained at that constant temperature for some period of time, so that the some internal changes may occur in the steel or metal. Then after over the soaking or holding time, the next and the last method, that is cooling. The component is allowed for the cooling with slow cooling. And in the annealing process, the slow cooling means the cooling takes place in the furnace itself. After over this stage 2, the furnace is switched off and the material is left free in the furnace and allowed for the cooling up to the room temperature. So it takes very long time to come up to the room temperature. So these are the stages that we have discussed many times in the earlier sessions. For any heat treatment process, the common stages are the heating, soaking, and the cooling. But the important thing that we have discussed today, that is the certain or definite temperature uh, up to which temperature the metal or alloy will be heated. Now the process. What is the process? The process is carried out by following the previous three stages: heating, soaking, and holding. The alloy component is heated about 50 degrees Celsius above the critical temperature, that is A3. What is critical temperature A3? This also about the critical temperature and lower critical temperature. Also, we have discussed in the earlier session with the help of the phase diagram. Once again, we will discuss in the later slides. So, critical temperature above A3 for hypoeutectoid steel and above the lower critical temperature, that is even for the hypereutectoid steel by the same temperature. And after that, it is hold for the some period of time at that temperature so that the internal changes may take place. Internal change means the grain structure of the material can be refined so that that's why the temperature is maintained constant for some period of time. After that, it is allowed for the slow cooling in the terminal. This is the process for the annealing heat treatment process. These are some important points. If higher temperature, that is ACM, critical temperature, is used for heating the steel, for example, if ACM higher temperature is used for heating the steel in the annealing process, so what will happen? It will show the following effects. Number one, it increases brittleness and does not satisfy the purpose of the annealing. So we will not prefer ACM temperature for the for heating the steel. ACM is the higher temperature that results in the more oxidation and decarbonization of the steel. So this is the drawback, this is the disadvantages. If the component or alloy is heated up to the above the ACM temperature. Number third is the grain coursing. Uh, grain coursing. Please correct spelling there. COARSINE. Grain coursing of austenite occurs above critical temperature, that is ACM. So these are the effects if ACM temperature is used for heating the steel. Yes. Now, what are the objectives of the full annealing heat treatment process? Why we are interested to apply the heat treatment process to a metal? So these are the objectives for which the heat treatment process annealing is used. Objectives number one, to refine. It is used to refine the grain size and the internal structure to improve the mechanical properties like strength and ductility. Yes, if we are interested to improve the properties of the material of the steel, their like strength and ductility. So it is possible with the help of heat treatment. Second, to remove gases trapped in the metal during initial casting. Yes, uh, during the casting process, that is the primary manufacturing process, and during this process, the some gases are trapped in the metal. So how to remove them? So heat treatment process, one of the method that removes the gases trapped in the metal during the initial casting. Third is to reduce the internal stresses produced due to working on the metal. Next, to improve machinability. Yes, the heat treatment process also improves the machinability of the metal so that the material can be machined easily. Next, to refine grain size of the structure. And last is to improve electrical and mechanical properties also. So these are the advantages of the heat treatment process. That's why heat treatment process preferred for the steel and alloy. Yes, after objectives. So this is the heating temperature band for the annealing process. In the previous slides, uh, I used the notations A3, A1, right? A1, this is A2, A2 is here above the eutectoid temperature line, A2, A3, and this is the ACM. So this line joining from 910 degrees Celsius to the eutectoid point, that line, that curve is known as A3 curve. This is the critical temperature, upper critical temperature. ACM is also the upper critical temperature, but A3 is critical temperature for the hypoeutectoid steel, and critical temperature, namely ACM, is the critical temperature for the zone hyper eutectoid steel. From 0 to zero point 0.8, there is a hypoeutectoid steel, and from 0.8 to 2.0, there is a hypereutectoid steel. So this is the phase diagram from the iron carbon diagram. On horizontal axis, we the percentage weight percentage of carbon has been shown, and the vertical axis, the temperature is shown in degree Celsius. This is 727 degrees Celsius or 725 degrees Celsius, and this line is known as eutectoid temperature line, denoted by the curve A1. This is A1, A3, ACM. And for annealing process, in the first slide, that during the definition we have seen that for the hypoeutectoid steel, the metal is heated about 50 degrees Celsius above the A3 curve. So this is A3 curve, this is A3 curve, and about 50 degrees Celsius above it. So like this, this is the curve that is above the about 50 degrees Celsius above the A3 curve. So this is the certain or definite temperature up to which the alloy or metal, that is hypereutectoid, will be heated. And if the metal or alloy is hypereutectoid steel, then what will be the limit of heating temperature? So the limit of the heating temperature is about 50 degrees Celsius above the A1. This is the A1 curve, and above it 50 degrees Celsius. So heating band temperature for the hypereutectoid steel will be like this, parallel to the A1 curve, but just above it, about 50 degrees Celsius. So this will be the definite certain temperature for the hypereutectoid steel. And for hypoeutectoid steel, this is the temperature around 50 degrees Celsius of the A3 curve. So this curve is known as heating temperature band for annealing process. Now, after using and after applying the heat treatment process, that is annealing, to the metal, that is steel or alloy. So what will be the result? What is the result? What is the outcome? So these are the expected, this is the expected result, expected microstructure or properties. First is coarse grain microstructure. After applying heat treatment process, if the material is tested, the microstructure of the material is tested, so it will be found coarse grain microstructure. This is the expected result. And if we check the properties of the material after applying the heat treatment process, then you will find lower strength, but you will find higher ductility. So these are the expected microstructure and properties of the metal or alloy after applying annealing heat treatment process. So thank you very much. Now let us conclude the session. What we have discussed in today's session, we we discussed about the annealing heat treatment process, a full annealing heat treatment process or conventional heat treatment process, in which we have discussed about the temperature band. What is the temperature band for the annealing process? That is around 50 degrees Celsius of the uh, A3 curve for hypoeutectoid steel, and 50 degrees Celsius above the A1 curve for hypereutectoid steel. And remaining stages are common: sorting or holding, then cooling. Cooling is carried out in the furnace itself, and this is the very slow cooling process and the annealing process, and it takes very long time to reduce the temperature up to the room temperature. After that, we have discussed the proper complete process of the heat treatment process. Then we have discussed if the ACM, then that is the upper critical temperature that is allowed for the heat treatment process, then what will happen? So also we have discussed the effects or drawbacks if we use the ACM temperature for heating the metal or alloy. And in the last, we have discussed the expected microstructure and the properties of the materials. Those are coarse grain microstructure, and in the properties, we found that lower strength and good ductility. So, thank you very much.